The method of Lagrange multipliers is a very helpful method in finding the maximum and minimum values of a function that is subject to another constraint or another function. What are we going to do? We're going to find the gradient of the first function. We're going to find the gradient of the second function. And then we're going to find the values that help us solve the system using the gradient of f equals to lambda gradient of g and the constraint g of x and y and z equals to k. What are we doing here? We're basically finding all of those values that satisfy these two vectors. The gradient of f and the gradient of g becomes parallel to each other. Remember that the gradient of f are the vectors that are perpendicular or orthogonal to level surfaces of the function, and the gradient of g are the vectors that are orthogonal to the level curves of g. So we are basically finding the points, the values that make the gradient of f to be parallel to the gradient of g. And again, you're solving this system together. That's the whole point that helps us to solve these x, y, and z's. Let us begin. Find the extreme values of the following function on unit circle. The unit circle is a constraint. Unit circle is x squared plus y squared equals to 1. But if we bring 1 to the other side, we can basically form this function or the constraint g. Set the partial derivative of f with respect to x equals to lambda partial derivative of g with respect to x, which is basically 2x equals to 2x lambda. Then partial derivative of f with respect to y, it must be equals to lambda times the partial derivative of g with respect to y. You get 4y equals to 2y times lambda. And at the same time, we know that x squared plus y squared is equal to 1, or basically you have x squared plus y squared minus 1 equal to 0 as well. From the very first equation, x can be equal to 0. If x is equal to 0, from the constraint, x squared plus y squared is equal to 1. So if you plug in 0 for your x, y becomes plus minus 1. So x is equal to 0, y can be 1, y can be negative 1. From this equation, lambda can be equal to 1. When lambda is equal to 1, well, what does it tell us? If you plug in 1 into the second equation, 4y equals to 2y lambda, 4y becomes 2y. It is only solvable when y is equal to 0. Okay, so far we have x equal to 0, y equals to plus minus 1. You have y equal to 0, but if you plug that into the constraint, which is x squared plus y squared equals to 1, it gives x equals to plus minus 1. Very good. So let's see, what do we have? The possible extreme values are 0 and 1, 0 and negative 1. Remember that each x must match each y. 0 and 1, 0 and negative 1. And from the second equation, 1 and 0, negative 1 and 0. Now, what are we going to do? We're going to find the z value of the function. Function f at 0 and 1 is equal to 2. Function f at 0 and negative 1 is equal to 2. Function f at 1 and 0 is just 1. Function f at -1 and 0 is equal to 1. So basically, the maximum value on this unit circle is equal to 2. And it happens at 2 points. These 2 points are 0 and 1, 0 and -1. The minimum value is equal to 1, which happens at 2 points, 1 and 0, -1 and 0. So this is the method of Lagrange multipliers. So we basically need to take the gradient of function f, set it equals to lambda, gradient of g, and start solving for x and y and take into consideration different scenarios using lambda. And as you can see, it requires a lot of algebra, everyone. We did a bit of calculus, but algebra plays an important role here. For example, if you look at this step here, let me highlight this using a different color. When you set 2x equals to 2x lambda, this is pure algebra. We are just checking to see for what values of x or lambda we have this equality. An obvious choice is x equal to 0. Another choice, lambda is equal to 1. But when x is equal to 0, we are using a constraint here. You plug this x into the constraint to find your y value, which is plus minus 1. Now, when lambda is equal to 1, well, what's the use of it? We can use lambda into the second equation here. Plug in lambda into the second equation, help us to get some values for your y, which becomes 0, and it plug in 0 into the constraint again, you get your x values, which are plus minus 1. So in total, you have 4 points, 0, 1, 0, -1, 1, 0, -1, 0, and you get 4 z values. The maximum is 2, the minimum is 1.